Hello learners, how are you? I hope you are having a good time and you are having a very good preparation for your exam. So today we are going to discuss about logarithm, which is our tips and tricks series 3. In our previous lesson, tips and tricks series 2, we have learned about exponential. In this lesson, we are going to discuss thoroughly about logarithm, and these two chapters, these two concepts, logarithm and exponentials, are closely related. Just a relationship and expression are the different, but the concepts is the same. And we'll learn step by step how they are related and how different mathematical operation we can do without calculator. So this is very important chapter. In every exam, all kind of exam, you will find couple of mathematical problems from exponential and logarithm. Some problems may come combinedly from these two concepts or separately from logarithm and exponential. Okay, so first of all, we'll start with exponential that we have learned before. We already know that as something power of 2, 0 gives us 1, and 2 power square gives us 2 multiply 2 equal to 4. Similarly, 2 power cube gives us 3. 3 times we have to multiply 2 by itself, so it will give us 3. Similarly, if we consider 3 cube, it will give us 3 multiply 3 times 27, and we can consider with 4 square, that means 16. Similarly, so these are the basic concepts of exponential we have discussed in our last lesson, where 2 is the base. For your remembrance, I'm telling you again, here 2 is the base a. This square, that means 2, is called exponent, and the results of these exponents is called argument. So for this case, here base is 3 and exponent is 3, argument is 27. So this expression, like exponential expression, can be expressed in different way, that is called logarithm. How we can express it, I will show you. So this term we can write log, base will come here, this base was 2 in this case, so we write bottom part, and then argument we have to write here, which is 4, equal to exponent. So the 2 is the exponent, 4 is the argument, and 2 is the base. So we can relate, right? This is very important for your calculation in future. Remember, this 2 actually base this, and this 4 is argument, which is a results when we consider the exponential expression, and these 2, the exponent comes here. This is the exponents come here. So now we can say what is the purpose of logarithm. Yes, by logarithm we can find exponents. That means if we think this way, this 4 comes when the base power 2 gives us 4, so we can consider this way. So logarithm is used for finding the exponential term for a certain base. Okay, similarly we can write here log, base is same 2 but argument is not, equal to 8. How about in this case? In this case, base has been changed, so here we can write log 3 argument is 27 and exponent is 3. So this is the logarithm relationship of exactly the relationship we found from exponential. So now we can write as a common term like log a argument is x equal to b. So this means what power of a gives us x. So remember, these two relationship is very important. Now we'll talk about properties. What are the properties of a, x and b? That means what numbers it can be, what numbers it cannot be. We will look one by one. Okay, so let's start with x, our argument. Let's consider a expression like this: log 2 0 equal to b. So is it possible? Can we find the value of this? Let's test it. So we can write this relationship in this way: the power of 2 is b equal to 0. So for what value of b we can find 0? Do you know? Negative or any fraction number or 0? No, it's not possible. Actually, for any value of b we can't get 0. Therefore this relationship is not possible. So we say value of x cannot be 0. However, okay, let's check another expression: log 2 power negative 1 equal to b. So we have written a new expression this way, where the argument is negative. We consider it negative 1, but it's same for negative 5 or whatever you say. However, let's write it the expression this way: 2 power b equal to negative 1. We have to find out a negative number. Now let's consider what value of b gives us negative 1. So we can see it's a positive number, base 2. It doesn't have any positive sign before, so a positive integers with powers will never give us negative numbers. If it is fraction, let's say b is a fraction half, it will give us root 2. If it is negative numbers, will give us fractions, but will never get negative 1. Therefore this expression also not possible, which we can write this way: x cannot be negative. Okay, or we can write x always greater than 0. So this expression is combined expression of these two two different situation. Okay, so this is very important. Now let's have another look: log 2. In this case we'll change the number of base, like the value of base, let's say, is 1, and here 8 equal to b. Okay, so in this situation we can write this expression like as exponent 1 power b equal to 8. So for what value of b will get 8. Is it possible? No. Whatever you consider as a value of b, we will never get 8. Therefore, this expression is not possible. We can simply write a, or base cannot be 1. Can base be 0? Let's take a look. Log base 0 equal to, argument is 8 equal to b. We can write this way: 0 power b equal to 8. So 0 power something always 0. Once again, a cannot be 0. But can a be a fraction number? Of course, it can be fraction number. Let's take a look here. Log half 2 equal to what? Equal to b, right? We'll find out the value of b. So we can write exponential relationship like half power b equal to argument 2. In this case, what value b gives us 2? Is very simple. Minus 1 will give us 2, because we know something minus, if we have a power negative 1, then the value will alter. So half will becomes 2, and that's exactly what we want. Therefore, the fraction is acceptable, but 0 can't, 1 also not possible. Can base be negative? Let's say negative 2, 8 equal to b. This expression we can write this way: negative 2 power b equal to 8. So we can get 8. Let's say if b equal to 3, it gives us negative 8, but we cannot get 8. It sometimes may be correct. Sometimes it will give you correct answer, but sometimes not. Let's consider another situation. If b equal to half means square root, right? So square root something negative complex number. So we can say the base a is greater than 0. Now let's represent this value on two-dimension number system or one-dimension number systems. So value of a we can write this way: this is 0, and from previous discussion we have learned that a can't be 1 and a also cannot be 0 and a greater than 0. We came a conclusion that a greater than 0. Therefore we can simply write this way. This is, let's say, 1, and we can highlight this area. Okay, so a greater than 0 but not equal to 1. Also a cannot be 0, but it can be fraction. This area 0 to 1 represents fraction. So base is base cannot be negative, but it can be fraction. And in case of b, here the 0, we have learned that b is always greater than 0 and b cannot be 0. Therefore we can highlight this area. So let's consider a special logarithm that is called decimal logarithm. Decimal, I believe that you understood. When we say decimal, that means base is 10, x equal to b. We'll see some relationship and some tricks to solve the problems. So let's start with something like log base 10 and 1000. So what is the value of this, right? The argument is 1000. We have to find out the exponent of base. So from the exponential relationship, we know 10 power something, which is b, have to be 1000, right? Now we have to find out the value of b, and we know that value of, the 3 gives us 1000. So if you closely look here, how many 0 is there? 3. Yes. So if after 1 the number of 0, we can simply count and then write it here. So that's the answer. Log 10, log base 10 1000 equal to 3. If we write log 10 100, so we can write is 2, because 10 power 2 gives us 100. 10 power 2 gives us 100. We can write 10 log 10. So what would be the answer? 1, right? Yes. 10 power 1 gives us 10. So again, if we look here, number of 0 is 2 after 1, and we can get the same answer. Like, we can relate this number here. Number of 0 is 1 and answer is 1. What if we write another expression like this, log 10? In this case, it becomes 1. So when we'll get 1, what power of 10 gives us 1? The 0. The 10 power 0 gives us 1, but we'll never get 0. Therefore, log 10 0 is not possible, we have discussed. So let's consider 0.1. This is a fraction. So what would be the answer? So if we write here that 10 power b equal to 0.1, and we have to find out the b. So in this case, we can simply simplify this expression. 0.1 means 1 by 10, right? So when we'll get 1 by 10? When value of b is negative 1. That means 10 inverse means 1 by 10. Therefore, our answer is negative 1. So we can relate, after 0, it starts, becomes negative, and it goes exactly the same distance. Here, the 1, like 10, the difference between argument is 10, here also 10, and it gives us the same results, same argument, but opposite signs. If we consider log 10 0.01, in this case we'll get negative 2. How about log 10 0.001? It will give us negative 3. Now take a look and let's find another relationship. From 10 to 100, the difference of argument is just 1 unit, 1 to 2. So we can simply say, if exponent, like argument, is 10 to 100 of a logarithmic term, then we'll get exponent 1 to 2. Let's have an example. log 10 base 150. It will give us a value like 1 point something, 1.4 or 1.45. okay, we have to calculate it. Similarly, if we consider here, if we write a expression like this, log 10 base 100, we can write maybe 9999, which will give us close to 2.99. okay, so I hope you understood this relationship, and you can guess by seeing the base and the argument what would be the results, and in which range the exponent will be lied. Log base 3 argument is 9 equal to, we know, 2. What if we just alter our, if we alter between these two, 9 becomes the base and base becomes the argument. So can you guess? 9 power what will give us 3? Okay, we'll find out later, but before that, let's have another expression related to this, like this: log 3 1/9. We just altered the argument. In this case, minus 2, right? Because we know 3 minus 2 gives us 1/3 square, which is 1/9. So when we alter something, alter the argument and base are the same, we get exactly the same exponent but opposite sign. Similarly, we can relate these two terminology. Let's write this way: log 9 1/3. So these two expression is just base is same, but argument I just altered the number. Here argument was 3, which is here 1/3. So when when argument is 3, how we can get this? Simply, if b is half, that means square root of 9 gives us 3. Then we can say okay, so okay, it gives us half, but here what will be the answer? In this case 1/3, we already understood it would be negative half, right? Just change the sign. In conclusion, we can say from here, if argument is greater than base, we'll get positive number, or we'll get also positive number, but this is fraction when argument is less than base. And when argument is fraction number 1/9, 1/3, it will give us negative exponent. Now we'll learn some formula. So in logarithm there are 3 famous formula. We'll learn them. This 3 formula is vital for mathematical, to solve mathematical problem. Let's write them one by one. Log A BC equal to log a base b plus log a base c. Similarly, we can write log b by c equal to log a by b minus log a by c. Log a b power m. M is a power of b of argument. This expression can be simplified m multiply log a power b this way. So tell me how we can simplify this expression. Log 2 base 2 and power half. So this is a power which we can write this way, half into log 2 base 2, and this term we know whenever the base and the argument are the same, then the log of them is 1. So the answer of this is half. Log 2 1 by 2. Maybe I have already discussed it. Yeah, so this is -1. This kind of problems usually comes in the exam, like complex problems. We can write a simple exercise for you, like log 5 by 1 by 25. How we can write it? So 1 by 25 we can write log 5 25 inverse log 5 square and into -1. So this comes as power -2. We can simply write here, and log base 5 argument 5 gives us 1. So our answer is -2. All right. Log 2 base is square root of 8. What is the answer? This is the simple example in mathematical problems, and in real examination you will encounter more complex problems. So I will recommend you practice more and more from textbooks. So we can write log 2 8 power half, square root means half. Then we can write log 2 power cube, and half remains as a power which will be multiplied with 3. So this term 2 power 3 it represents 8, right? It gives us 8. I just simplified 8 into 2 power 3. So we can write log 2 is the base, 2 power 3 by 2, and we can apply the formula. 3 by 2 comes back, and log 2 base 2 gives us 1. This gives us 1. So our answer is 3 by 2. So that is all for today.